This conference will now be recorded.
So, very good evening, students. Today we will be concluding this electrostatic revision part. So, we have collected few questions from previous year's JEE advanced paper. So, this is from 2021. Oh, shit. So, let us read the problem and try to solve them as soon as possible. So, 2 point charges minus q and plus q by root 3 are placed in the xy plane at origin 0.0 as you see here, and a point at 2,0, which is this place. Okay, so this is the coordinate of the other charge q by plus q by root 3 respectively as shown in the figure. This results in an equipotential circle of radius r. So what this problem is saying is that there are 2 point charges. One is minus q, which is at the origin. Another one is q by root 3, positive q by root 3, which is placed at 2,0. That means on the x-axis. Okay. Due to the presence of these two charges, there will be a equipotential surface, a region of equipotential surface. Sorry, circular equipotential region will be created where the potential is V is equal to 0. That means in this region of circular equipotential surface, everywhere the potential is 0. And radius of this circle is capital R. It is in the xy plane. Its center is at, see, if this is the center, then it has its coordinate b comma 0. So all lengths are measured in meters. You have to actually calculate the value of r, that means the radius of the equipotential circular region, and you have to find out the coordinate of the center. Okay, b comma 0 is the coordinate of the center, so you have to find out b. So how to solve this problem? It is very simple. Let us see here. See, I have 2 point charges, so potential is 0 here, right? Potential is 0. Let us take any point in this circular region P which has coordinate x or y. Okay, so you can see here I am just taking a point P which has coordinate x or y from the origin. Okay, from the origin. All right, so potential at this P also will be 0 according to the question. So potential is equal to 0 at P comma xy. Now what we can do, we can just find out the potential for this minus q charge at this point P, and potential for potential created by this charge plus q by root 3 at P, and then sum them up to 0, and then we will be able to get the answer. Let us see. So the potential due to minus q charge, let us say V1, due to minus q, I am writing due to minus q it is, see, k q with a minus sign by, see, let us say the distance between the origin and this point P is R1. R1, okay, so where R1 is square root of x square plus y square, position vector, or position, yeah, position vector, magnitude of the position vector. Now you have to find out potential V2 for q by root 3, positive q by root 3. This is k q by root 3 into R2, where R2 is actually square root of, see, the coordinate, this, so coordinate of this two we have to actually write like this, y square, because y coordinate of this point is 0 again, so this is y square. Okay, so according to the problem, V1 plus V2 will be 0, which implies that minus kq1 by R1 plus kq by root 3 into R2 is equal to 0, which again implies, uh, see, this kq will, anyway, that will get cancelled, so in the numerator there will be 1 for both of them if I take them on either side, and see, we will get actually R1 is equal to root 3 R2. So this is a relationship between R1 and R2 we get. Okay, now see, if I put the value of R1 and R2, in fact we can just make them square. So this root 3 will be 3 then. Okay, now see this equation, if we solve for x and y, let us see what we get. Okay, so I'll go to the previous page maybe. Okay, we have a relationship R1 equal to R1 equal to 3, sorry, R1 square is equal to 3 R2 square. Okay, so R1 was x square plus y square, and here it is 3 x minus 2 whole square plus y square with the bracket over here. So see here, if we just break this into, like if we just split it with the algebraic identity a square a minus b whole square with that identity, then what we get in the right hand side? So 3 here x square minus 4x plus 4, and it is 3y square again. Okay, so look, then we'll get here, see this 3, so this will be 2x square, and this will be again, if we bring all of them here, okay, okay, so this will be 2y square, and along with that there will be 12 this and plus 12. Okay, so if we try to make see 2y square anyway, we can just take common of 2, then we have this we have minus 6 plus 6 plus y square. So this part we can just make whole square in the form of whole square. See what we can do, x minus 3 whole square plus y square plus 3, sorry, minus 3. So there will be 1 minus 3, 1 minus 3, it is equal to 0 obviously, minus 3, so 3 will be on the right hand side, so we can write this as square of root over 3. Okay, so then we have got an equation of circle. Okay, so see here, this r is actually root 3, then, and the coordinate anyway, b I have to find out. B means the, see the coordinate of the center is b0, that means x coordinate, y coordinate anyway is 0, so x is equal to 3, so this is equal to b. So x is equal to, sorry, b is equal to 3 and r is equal to root over 3. So this is the answer. Okay, we'll go to the next page, next problem. So see here, the question is, a circular disk of radius capital R carries surface charge density sigma is equal to sigma naught whole into 1 minus small r by capital R, where sigma naught is a constant and r is the distance from the center of the disk. Electric flux through a large spherical surface that encloses the charged disk completely is phi 0. That means, see, if I consider this to be the circular disk, this one having radius capital R, okay, having radius capital R, and the distance from here is varying like this R, okay, this is the distance varying from the center or increasing from the center in this way. Okay, this is the small r. So the density, charge density varies in this way. That means as the distance increases, the charge density also decreases. That decreases because this is in the numerator. Anyway, the question is that the electric flux is given phi 0 when the disk is actually completely enclosed by a spherical, okay, so enclosed by, okay, sorry, the electric flux through a large spherical surface, that encloses the charge disk completely. When the disk is completely enclosed, so that time what is the flux through the surface, this spherical surface, okay, and electric flux through another spherical surface of radius r by 4. So there are two spherical surfaces. One is r having radius r is equal to capital R by 4, and another one has small r, which is actually much greater than the radius. Okay, that means inner point and outer point, that is the main point. So see, you have to find out electric flux. We know electric flux according to Gauss's law, phi is equal to the charge enclosed by epsilon naught. Okay, so here charge densities are given, charge density is given, we have to find out the total charge enclosed by each spherical surfaces. Then things are done. So I can write for first one phi 0, which is, suppose this is dq by epsilon naught. So what is this dq? Dq is the spherical, sorry, the charge enclosed by the spherical surface which is outside. Outside means, see, I can take the limit 0 to capital R. Okay, and dq I can write, since it is a disk, so I have to take area 2 pi r dr into sigma. So sigma r into 2 pi r and dr. Since it is a disk, and down it will be epsilon naught anyway. Okay, all right. So we can finally write this as 1 over epsilon naught, and 0 to r, sigma is given as sigma 0 1 minus small r by r 2 pi r dr. Okay, if we uh, write the plus for the other one, so what will be the case? In that case, simply we can write, see, phi it is given, so simply the limit will be changed, simply the limit will be different, otherwise things are same. So this is the limit in sigma 1 minus r by r 2 pi r dr and dr. Okay, now let us take the ratio phi 0 by phi. So phi 0, see, anyway these terms are common. See, sigma 0, then 2 pi, and this epsilon naught, these are common term in both cases. We can just strike them off. Okay, after taking the ratio, we got actually 0 to r, then this is 1 minus r by capital R, and here it is r dr, and in the denominator limit is 0 to r by 4, this is r by r. Okay, if we do the integration part and take the proper limit, then we get here r square by 2, and here r square, so r cube by r, it will be actually r square by 3. Okay, or I'll write r cube by 3r, so 1 r will cancel each other, so it will be r square by 3, r square by 3 in the numerator. In the denominator, see, here also it will be r square, that means here r by, see, r square by 2, that means r square by 2 into 16, and r cube by 3, that means anyway this will be r square, 3 means 3 will be anyway there, and 64. Okay, so this is the thing. Now look, in the numerator it will be, see, it will be 6, so r square by 6 only, r square by 6. What about this? See, we'll take r square by 32 common, so it will be 1 minus 1 over 6. Okay, so see, anyway this is 32, so r square goes off, and okay, let me just write here, this is r square by 6 into 32, here it will be 5, that means r square by 6 into 32 into 6 by 5 into r square. Okay, so this goes with this, and it is 6.4. Okay, so this is the ratio which is given. So in this, actually this is a fill in the blanks type question, so it will be 6.4. Okay, we'll go to the next problem. So this problem is again an interesting problem. What is this problem saying? According to this problem, there is a uniform electric field, E, which is given as minus 400 root 3 y Newton, Newton per coulomb, is applied in a region. You can see this region, there is electric field in the vertical downward direction. In this case, it is in the negative y direction. Say this is x direction, this is y direction. So electric field is in the negative y direction. Anyway, a charged particle of mass m carrying positive charge small q projected in the region with an initial speed 2 root, I think this is root 10, not root 11, this is root 10, 2 root 10 into 10 to the power 6 meter per second. The particle is aimed to hit at a target T, you see here, which is 5 meter away from its entry point. Entry point charge is taking entry over here. So entry point into the field as shown in the figure schematically. So here you have to take m by q as 10 to the power 10 kg per coulomb. M by q. So mass by charge is given as 10 to the power 10 kg per coulomb. This we can take. I'll tell you once again, I'll just tell you the sum or substance of this problem. So there is a region like this. You can see, you can just think this is in the xy plane. So this region contains uniform electric field as you see, and the electric field is given as this. Okay, E is equal to minus 400 root 3 y Newton per coulomb. Now a charged particle having positive q charge is actually projected from here, as you see in this region, with an initial velocity 2 root 10 into 10 to the power 6 meter per second, with an angle, some angle theta, as you see, and aim was to hit the ground over here at T. So this is kind of a projectile problem. Okay, just we have to find out what is the range. So T is actually, range is given, range is 5 meter, it is given. So we have to see what are the options here. So in this case, you know, when you leave a projectile like this or project an object in this way, so there will be two velocities, as you know. One will be along this direction, okay, x direction, another one will be in the y direction. But in this case, you look the charged particle, this is a charged particle, so it will actually experience one force in this direction, q into E. This is the force it will experience. So in the downward direction, what is the gravitational acceleration? Sorry, what is the acceleration? What is the acceleration due to this electric field? So downward direction, there will be acceleration q into E by m. This is the acceleration in the downward direction. Okay, in this region of electric field. So if we look at this this acceleration, so we can just use that. All right, so then we can see the question has the options like the particle will hit t if the particle is projected at an angle 45 degree from the horizontal. So look, this range is given anyway. We know the range formula for the range is u square sine 2 theta by a y. Okay, in this case we can find them out. Okay, so I can see that I can write here as range 5 if I get the acceleration a y, and if I get, see, initial velocity is already given, so I can find out what is theta. Now the particle will hit t if the particle is projected at angle this, so I can find out the angle from there itself. Okay, so angle problem is gone. Now time we can find out. We can find out that, okay, so time means how much it will take up to here. So we have time of flight, that formula will be using here. Okay, all right, so with this, let us try to solve this problem. So as you know, the acceleration due to the electric field will be like this. Okay, q into e, so I can find out acceleration y is equal to q into e by m, and you look here, q by m, you have been given over here. So m by q is given, q by m you can find out 10 to the minus 10 m q by m, 10 to the power. So e is given already. What is that? 400 root 3 into 10 to the power root 3. Okay, so that was y cap. I hope that was y cap. This is electric field. Okay, so along the y direction, negative y direction. Okay, so this is yeah, so I have then, okay, so q by m, let me just check once again, q by m or m by q is given. M by q is given. M by q is given. Q into E, so Q by M anyway, so this will be actually I need to check this value. I hope there is some problem in this. So M by Q maybe this is minus 10 to the power 10, 10 to the power minus 10. Okay, 10 to the power minus 10. It is not the 10 to the power 10. It is 10 to the power minus 10. Okay, so it is 10 to the power minus 10. Therefore, it is 10 to the power 10 here. Okay, this is meter per second square. This is the acceleration in the vertical direction we get. Okay, now you have to find out whether angle is like angle of projection is 45 or 30 or 60 from the horizontal. Okay, so for that we'll go with the range formula. We know the range is equal to u square sine 2 theta by AY. So this is yes, so Q by M I have already used. So sine square 2 theta, sorry, U square sine 2 theta, U square sine 2 theta, U is actually given as 2 root 10 into 10 to the power 6 meter per second, 10 to the power 6 meter per second whole square. Okay, and sine 2 theta divided by AY. AY, I'm just taking the magnitude here for the sake of calculation. This is 10 to the power 10 alone. Okay, so what we get here is, so this will be 4, 10, and this is 10 to the power 12 divided by 100 root 3, 10 to the power 10. So eventually what we get, and left hand side is 5, range is 5 as you see in the figure. Okay, range is 5. So here there will be 2 extra, so it is and it will be actually 3, and here it is 2 again, root 3 by 2. Sine 2 theta is equal to root 3 by 2. So sine 2 theta is equal to root 3 by 2, and this value implies that 2 theta could be 30 or 120. Okay, sorry, root 3 by 2 means 60. It is 60, or root 2 theta should be this. That means theta could be 30 degree or 60 degree. Okay, so one answer is obtained. So this is correct, but this is not correct. Now time taken by the particle to hit the target. So time taken by the particle to hit the target. So we have got one answer. We can actually erase this out. Okay, I will just erase this. Let us just write the answer. Okay, we have got this too. Now, so what is the time? Time is actually given by 2u sine theta by ay. 2u sine theta by ay. So what is this u? U initial velocity is given already. So 2u is 2 root 10 into 10 to the power 6 sine theta. I can take twice, well, like two values. Let us take first sine 30. So it will be half divided by ay is 400 root 3. Okay, into 10 to the power 10. So this 1 2 will get cancelled. Here look, this will give you ay. Okay, so this is actually, see, this is 10 to the power 12 if I just write. Okay, so this is 2, this with this get cancelled, So we will get actually root 10 divided by 2 root 3 into 10 to the power minus 6. Okay, this is the second. So in this case we can just write 10 root 10 by root 12 and this as microsecond. So this is 5 by 6 microsecond. So one is gone. Now other time another one, if I just put the value of theta to be 60 degree, then look directly I'll write here 2 root 10 into 10 to the power 6. This will be root 3 by 2. So here it is already 4 into root 3 into then it is 2 and here it is 10 to the power 12. So look here what you get, root 3 get cancelled here, this 2 get cancelled here, it will be 2 again. So what I will get actually, see, this will be root 10 by 2 into 10 to the power minus 6 second. So I can just bring both of them into the root. So this is 4, so 5 by 2. So square root of this is microsecond. So 5 by square root of 5 by 2 microsecond. So the second option, sorry, third option, C is correct. Then obviously this is not correct. Okay. So this is how we have solved this problem. These are actually from JEE advanced paper. Now I'll just take you through another interesting problem that is actually very important for NEET, etc. This is a very interesting problem to solve. Let us first read the problem and try to understand the problem. The problem says a thin semicircular ring of radius capital R has positive charge Q distributed uniformly over it. The net electric field at the center. What will be the electric field at the center? Net electric field at the center. You have to find out that. So let me give you the options here. First option says it will be Q by 4 pi square epsilon naught R square along the J direction electric field, then it is minus Q by 4 pi square epsilon naught R square J, that means it is in the downward direction. Then option C says minus Q by 2 pi square epsilon naught R square, this is J cap again, and D says it is Q by 2 pi square epsilon naught R square J cap. Okay, so this is the problem you have to solve. So how to solve this problem? So to solve this problem, we have to see this is a semicircular ring. That means here there is no mass, no charge here. All the charges are actually over the circumference of a semicircle. That means we can think this a small line element, small line element, small line element, delta L. I can take a small line element delta L. Anyway, this will be fixed. Okay, let me just show you this figure. I have just taken a line element of the semicircular ring, this one. This has length here. This has length delta L, and that delta L is making an angle delta theta at the center, as you see. The ends of these two making an angle delta theta, say. Okay, and since it is a linear charge, so I can just think of lambda is equal to total charge q, so lambda will be q by pi r, because it is semicircular ring. Okay, lambda is the linear charge density, as I am just taking a small charge on the, see, if this is capital R, these are R, these are the radius. So dl will be how much? Capital R d theta, right? This is simply from, see, the arc length divided by R is angle. Okay, so from there, now if you want to find out charge on this particular element, length element, so that you can find out as lambda into dl. So that means R lambda into d theta. If we put the value of lambda over here, then look what we get. So R lambda is q by pi r into delta theta. So d theta. So this r goes, so q by pi d theta. If we require, we can find out that in terms of q and theta. Okay, but anyway, I can write it down, lambda r d theta, lambda r d theta right now. Okay, I'll just take this up to here. Let me just erase, not to confuse you this. So I have this length element which has some charge delta q. Now look, if I have a charge over here, it will produce electric field. Which direction? In this direction, right? In this direction, direct radially outward. So electric field will be in this way through the center. Okay, through the center. So it will actually make angle theta. If this is the radius vector. Okay, so this makes an angle theta. So this also will be theta, right? So this is the dE. Because of this particular charge delta q, this electric field is produced in this direction, right? That makes an angle theta with the vertical or y direction. Now I can just break the component into two, one along this way, another along this way. So one is this way, dE cos of theta, another one is dE sine of theta. Okay, now look, if I take symmetrically another line element over here like this with the same d theta here, and this is theta, then due to that also the electric field will be in this way somewhere. Okay, since the length element is delta L, the charge also will be same, so the dE strength of this elemental electric field due to this element will be the same again, so it will be acting in this way symmetrically. So dE cos theta again added up by that, and another component dE sine theta, which will actually cancel the previous one if this dl are symmetrically situated. Okay, so this is the thing. So we get actually electric field dE cos theta, which we have to integrate. Okay, so dE cos theta, this is the element. So theta is taken from here. Look, theta is taken from here, and this is pi by 2. So here you have to just take okay, so this is 0 to 2 into 0 to pi by 2, 2 into 0 to pi by 2. I can take limit like this, 2 into 0 to pi by 2, or minus pi by 2 plus pi by 2. Okay, so what is dE then? dE you have to find out. dE means dq by k, take this k, the constant, dq by 4 pi epsilon naught r square. Okay, so here r is the capital R only, capital R. So in place of, so here I can write 2 into 0 to pi by 2 k r lambda dq is k dq means r lambda d theta divided by r square. Okay, divided by r square, and cos theta, and you obviously see this is in the negative j direction. Okay, negative j direction. Okay, we have to integrate this. So look here, it is in here 2 0 to pi by 2, k will be out, lambda will be out, so lambda 2 lambda k, let me write it here nicely, or 2k lambda. Okay, 2k lambda 0 to pi by 2, 0 to pi by 2. Now this will be d theta by r, so that r is also constant, and here integration will be for just cos theta d theta. Okay, so what is this cos theta d theta? So this will be minus sin theta, so 2k lambda by r, it is minus sin theta, so minus sin theta, theta is pi by 2, so this will be 1. So this is the thing. Now let us see, our options are given like this. In terms of q, we have to now find out what is lambda. We have to write lambda is equal to pi r, like that. Okay, then we'll get, okay, actually dt, so there will be, this will be plus because sine is coming. So finally we get electric field is equal to 2k lambda r by r square, it is 2k lambda by r, 2k lambda by r into 1. It is integration is coming as 1, so let us not worry about that. So lambda, let us put the value of lambda 2k, then this q by pi r, so this is pi r square. I can just make it k, I'll just write 4 pi epsilon naught, and here pi r square. So what we get, 2q by 4 pi square, or we can write 2 pi here, 2 pi square. Let us remove this k, 2 pi square epsilon naught. Here one r was there down, that's why it is becoming r square, so it is here r square. So the final result is actually q by 2 pi square epsilon naught r square. So this is the electric field, and it is obviously, you have seen, this is along minus J direction. So we have answer here, this one. Option C is the correct answer for this question. Okay, so with this we'll stop it here, and we have more or less completed many problems from JEE advanced papers. Now we'll go to the next chapter, that is electricity and Kirchhoff's law, etc., in the next class. Okay, bye for today. Thank you for your patience.